Good evening and welcome. Today we are... Alright, hold on, I'm just sorting out my microphone. This is bad. This is very bad. Right, hello. Right, this time. Good evening and welcome. Tonight I will be going over trying to do some debugging on a 6502 processor. Real hardware. So the way it's set up now is with a WASMON monitor. Very basic. It doesn't run the basic command, not the way I want it anyway, and there are other issues with it as well, as my Intel code loading does not work as well as what I hope it would. Let's see here, as for example, it has now crashed. So this is after adding extra code into to get it to work. So before I carry on, let's see here. I'm just going to go to my notes and I'm going to bring up the CA65 users guide, or I thought I was there we go. I thought I was organized. I don't think I'm organized. Never am. Alright, so the force break. So what does the force break do? It is a software interrupt that the user, you, me, anybody else, can use to do an interrupt. It's a forced interrupt. The processor, when it does get a forced interrupt, or this one, it will set, I'm just going to go grab my notes. Where are my notes? It will push the high and low and the flags onto the stack in that order. So 3 bytes, and then calls location, the address at location FFE. So if I go back to my code, sorry if it feels like I'm erasing a little bit, my code, and where are we hiding here? Monitor, and bring you guys into editor. There we go. So this is the code that starts off my basic. It should never get to that line there. Agreed. Break. The way it works, I'm not sure if I do need a no-op for the way I'm going to be using it, but if I was to put a I'm just going to treat it as a 2-byte instruction. It's either 2-byte or 3-byte instructions that it's replaced. The JSR here is typically 1 byte, 2 bytes. Same with this one here. Actually, that's 3 bytes, and that's 3 bytes again. RTS is 1. Now tonight I will be creating the code for just a very simple interrupt. What we're looking to do is save. Where are we hiding here? No, that's. I thought I got rid of that stuff. Okay, so FDC is still in there. Alright, basic still there. Clearbox. Here we go. So we're going to store the program status word into that location. So we're going to be pulling off the stack. That's the first location that comes off the stack. This is the second one that comes off the stack, and then that's the third one that comes off the stack. And then from there we will tell the computer to go into a soft reboot, and hopefully those memory locations will still be in there. So first things first is we disable interrupts, and that is, if I go to the book, SCI, set interrupt, but it's not. It's kind of funny that it says SCI to set interrupt disable. So SCI, oh, I don't want that. So disable interrupts SCI, and then we enable the interrupts again, CLI. and then we're going to do the call to let's see here, I'm just going to do soft reset. So that just soft resets back to the processor, to the start. And let's actually just check to see if that works, or we could just go the whole hog. Let's go the whole hog. I got a book in front of me anyway, so go to the page and really. Okay, so the first things first is it doesn't say on the book whether you set the interrupt flag or you cleared the interrupt flag. First one is pull the status register from the stack, which is PLA, and yeah, so pull status register, so it says restore it as well, so pull it off and push it back on, and A will still contain that value. Let's see here, PLA, take it off and store it into location. Where did we say we're storing it? Sorry, I got distracted. It's all the way up the top. All the way up the top. Let's rip these out. Let's just copy them. Bring them all the way down. I'm going to comment them out because that is what we can do. I like to have them stored up the top, but it makes it harder here. So BRK underscore PSW. I'm going to do PLA again, which is going to give us the next one it brings off is the, let's go to my notes, low byte. Oops. Break AL address low, and we PLA and then we STA break HL. Alright, so that's as simple as what we can do. Unfortunately, the other thing we can do is we can actually save quite a bit. Register A. We can literally save A. 53. We can save register X. We can save register Y. The problem is we are going to have trouble figuring out where other things are as well. So let's do STA REG, no, BRK RA, and we transfer X to A, and then we store A BR register X and transfer Y. Where's Y? Y to A, and we STA BRK RY. Right, hopefully that all makes sense. So we'll have a deeper understanding of what is going on with these there's registers here. Alright, next bit is to compile it, run it, check it, and see if that makes sense to me. Put it to the compiler, and if that works. "10 minutes later." Alright, 50, 55, cool. Alright, that's off, take that out. Alright, so if you guys have watched any of the early ones, you'll notice that I have changed the editor. I'm also using CA65. If I go to DOS, where's DOS? We can bring up the DOS. Build bat, crap. HHL. Back all the way down there. AL, it's AH. Okay, so that gives the calling address where the break was introduced, which could be an interesting thing. Is if we do have another break, we can go through the AH and AL, and to say if we've got 3 different breaks in different locations, we can say, okay, it was the 3rd break, not the 1st or the 2nd break that went off in a different direction than what we expected. So hopefully this will go back to a soft reset after it's done. Let's get rid of that comment there. Put it in the right place. Okay. And storage A, storage B. Now some of you may be thinking a bit ahead like I just did, and if we had the interrupt vector being reset every 1/60th a second, we can set up a clock or multitasking as well. But at this stage, so X, at this stage, that's getting a bit ahead of us. Actually, we could really do that. Reg flags. Though I don't think we can restore flags though. Okay. Okay, so one more thing. Control X. Control V. Now, the reason we've got interrupts enabled and disabled, or disabled and enabled, is that we do not want anything interesting happening in between this bit here, which will muck everything up. The results will be not great. Alright, this time. And we go to compile it. Just realised you guys couldn't see half of that stuff, so builds. Alright, let's get rid of that. DOS. And compile, load. What did that build as? How am I building it? Monitor, monitor.bin. Fill with FF, specify. Okay, the other thing I wanted to do was fill it with EA, which is no op. Okay, so anything unused is filled with EA. FF is, this is for the RAM, so if the processor goes outside of its scope, it's not trying to do some of the interesting code. It's just going to go, oh, no up, no up, no up. I'll just keep going, keep going, keep going. And I'll just quickly look and see what FF would be. I've got an F8, F1. This is this SPC subject carry role. Then you got to pick and pull processor status from stack. We don't want to do that, which means we can we push? We can save, we can in quotes save the stack. So if we push accumulator to stack, which is the instead of push processor status to stack, we push accumulators onto stack. When we can do multi-programming with that. That's cool. All right. I don't know. Program placing error, and we've placed it in the wrong place. Nope, we just didn't. Alright, redo. Alright, just had a small issue with not cinching down the clipper on the programmer. Always remember to do that. Alright, put the chip in and bring up putty. You guys can still see putty, and switch on. Works as expected. Okay, I just did the 0 page there. So we'll be seeing interesting stuff through here through the 50. And what I'll do is bring up the list. And we are looking for the address to jump to. So fingers crossed this works. Iron basic. There we go. This is the first bit we're going to be loading. Okay, so which is at address E49. And it's not E49. What is it? E127 is F127. Okay, it's F. This should read F anyway, this bit down through here. For some reason it's oh, is it E127? It is E. My mistake, it is. Control C, run basic, here we go. See, E49C. Okay, so E49C, that is our run basic code. So if I type that number again in, see, and you should see the break is there, 00EA. Fingers crossed. So, two things are going to happen here. It just hangs, doesn't want to do anything about it, or it will do the break and what's the word? Go back to soft, do a soft reset. Loading basic, and that's all I did. We didn't even get, I don't even know if we've got to that bit there. Oh, right. Maybe it didn't. Because I've done the set the stack there. destroyed the stack, and then it should still do that though. Okay, so the problem is that on reboot, yes, okay, still reset, and .100. I thought it was going to be that simple, but it's not. The 90's got something. I'm not sure what 90 is. Am I supposed to clear that as well? Okay. Yeah, maybe I should go into 200 as well. That'll give me the stack. But we might not be able to see all of it. Okay, so here is, okay, what we'll do is hopefully that worked. Nope. Okay. I might have broke all around ass backwards. Backspace doesn't work for me too. So these are address calls onto the stack, and let's see, 13A0, 38A0, C2. It doesn't make sense, does it? Nope. 9C, run. Yeah, it just shows loading basic, and then we just go to the just hangs there. And we can't do anything about it. Let's have a look, Mr. Google. Okay, so break. Okay, similar to an IRQ. Alright, let's have a look. Interrupt requests. Where are we guys hiding? Yeah, 167 is a handler for an IRQ. Okay, so clear interrupt, disable bits. It's very close to the break. There we go. RTI. But that doesn't make sense either. Oh, you know what we could do? Yes, RTI. So, now how I was going on about before. Alright, let's see here. Let's go back to my interrupt handler. So, JSR. Now, this soft reset's not going to work. Oh, this is not the right one. We just want this one here. So, just JSR soft reset's not going to work. What it needs to be is load accumulator reset, and it's the low side, and then we push A, and then we load accumulator hash high side, and it's the soft reset, and then RTI, return from interrupt. But it's the other way around. It's the high ones first and then the low one. So it pushes the high, then the low. Cool. Alright, so they all should be off the stack, and let's see if that works. Let's turn that off and compile it. Compiled OK, and load it into the ROM. How we do for time? I'm going to make this one a short one tonight. The next bit is up to us to determine how, or interpret how that data is being used. We'll just leave it at that. Program. Editor, and that I can see the editor and putty, and let's reset the computer. Okay, we know that's working. Our code we're jumping to is in the list, and it's the video processor, and run basic is A90D, which is E49C run. Okay, notice something different. It didn't do a new line. It just crashed. Well, it didn't crash, it did something different. Okay, so 3BFF, which is FF3B, and that is our video processor there, so that's being called properly. Okay, just get rid of the NMI. We're not worried about that. Which could be interesting if that's actually being triggered. And a quick look at the documentation for break. Okay, that's a little bit of okay. Just going over some opcodes. Okay, that's the same as pretty much a lot of the data is the same. Okay, alright. 2010 internals of break IRQ EMI and reset on a MOS 6502. Okay. I've read this before. It says a lot, but not much. Okay, there's a 6502 programming manual. And branching. Ooh, this is gold. Break command 144. I don't think it's going to do 144, but we get close to it. Alright, I'm going to bring you into this one here. So this is what I have found on Chrome, Putty, and okay, return from interrupts. What page is this? 34. We want 144, and we're at 150, 143, and 4. Okay. Okay, that's a lot of symbolic notation. Anybody understand that? Just make it as simple as possible. He may decide. That's nice. Break interrupt processing. Alright, this is the same as that bit there, and through there is the same as what I've got in the book. The book is let's see, 6502 to software design by Leo J. Scanlon. And it's quite an interesting book, but break programming. So you load status register and restore back onto the stack. Okay, so we're not restoring back onto the stack, are we? So if we in the wrong place. Restore register flags, and then we're going to just break it a little bit here. And restore register flag. Oh wait. No, we don't need to do that because we're taking it off the stack. PLA is the number of, was the opcode I want, isn't it? Push, yeah, PLA. Yeah, because I don't want to push it back onto the stack, because if I push it back onto the stack, I am not going to get any of my address high, address low, and program status word, which also means, let's see, not my cheats and my notes, it goes high, low, then PSW, going PSW, low, and high, the PSW and flags. Oh, do this. Okay. Yeah, there's no confusion. So LH, we got there in the right way. High, low, flags. So flags, low, high, and enable interrupts there. And then we just do a return from interrupt there. RTS and no up and not really needed. So the question is, why is it not working? And can I do that? Because if I do that here, pushes, pops, cool. That should be safe to do. So this way here, I know if we are getting into that bit, and then if we're in here, show message, and we'll get rid of that, get rid of the echo. Let's see, show message. Okay, cool. All right. Turn the processor off. Find our programmer. Build it. Built. Load it. Alright, what can you guys see? Nothing. And bring putty back up. Let's move it into the middle for you. Let's move it to the side here. Now let's fire up the computer, and it's loaded. And it's okay, just an arbitrary number. The area we want to run is run basic, yes, which is A9OD E49C. And that's the basic code. Now we try it again, E49C R, and see, it didn't do that second the second jump, did it? It didn't even want to know about it. So right. Did the break and the no up, we're changing the stack address again. Why I'm doing that, I'm pretty sure I don't know. Basic may retrash it. I honestly couldn't say. just the stack pointer for the stack. But if we find where echo is, which is all the way up here, which is up here. Okay, let's get a monitor. Okay, this is echo, which is really just character out, but we call it echo. Echo is also used in the stack. So why am I pushing it twice? I really need to just push it once. Okay, so let's get rid of that one and that one. We can only do it once. I think this breaks it for some reason. But while we're here, we can also check to see if that monitor was in an interesting area. And at the end here, we should have a lot of jumps. No? Okay, so let's try to figure this out. So when we boot, that's not what we wanted. So we set the stack address, clear decimal, query carry, enable interrupts, load address, start up. First one is JSR. Oh, could we just be running out of stack space because of some stupid error I've made? Because that's what that looks like. That looks like we've been pushing a lot. We haven't matched up our push and pull somewhere. And I'm just running out of stack space. Alright, let's go back to here. So save A because we're saving A because A comes in. Our serial command is then coming in from, we're checking to see if the serial command works. If it doesn't work, then it's we break up to not ready, we do the loop until it's ready, and then we restore A, we AND with it, and we store A into the serial data, and then we return from the sender, return from the sender. So show message echo. Okay, let's try the new echo, see if that solves it. And that could be part of the issue, is that we're pushing more than we're pulling, and it's just ended up trashing our stack. And when we get to that point, we're just unfortunately out of stack. Let's see the compiler. Okay, so there's an easy way to find out if we're pushing more than pulling. Monitor bin. Alright, just keep this one under now. Operation OK. And bring up the monitor. Oh, I gotta take the EEPROM out before I turn it on. There's nothing on there for it to work. Plug that in, turn that on. Okay, so, but if that was the case, then we shouldn't be running out of space here. It should be, at this point, we've had it off. And we just get that. Okay. We do need those in there. Push A, save it, restore A. Must be used elsewhere. Now, what we can do, now if you're thinking like I'm thinking, we go find here, and this place, 2D, 24, 20, 21, 22. Mess with echo for a bit and remove some pushes and pulls. Alright, so this is where we go. Okay, we saved A, we don't care. We go STA, store A into echo, load A, 0, cool. We don't need that. Oop. Okay, so that saves us 1, 2, 3 instructions, 1 piece of memory. PLA is, I'm going to turn my light on because I can't actually see. It's dark in here. So we use up 1 byte. We use up 1 byte, but are we saving anything by a store? It's all going to 0 page and a load accumulator with memory. 0 pages 2 bytes, 3 cycles, and this is just an aside. Push accumulator. PHA is 1 byte 3 cycles. Okay. We're not gaining much. We're not gaining much at all by using the 0 page and the other things. Let's see here. Oh, I better do this. Okay, so where is store accumulator serial data? And let's see if this works. Alright, that's off. Because it didn't even print any Lyris data. Let's build it. Grab it. Cool, it's programmed, and place it in. Go to my editor and go to putty. Turn it on. Oh, let's reset. Turn it on. And still broken. Store accumulator error echo. '85. 85 is the 0 page, of course. Or is it? Better be the 0 page. STA 0 page. 85 2 bytes. Yep. 23 is the location. And A5, which is load accumulator. Where are we hiding? Which is 0 page. A5 2 bytes 3 cycles. So 6 cycles in total compared to 1, 2, 6, 12 cycles. So it is faster, but it doesn't work. Ah, you see my dilemma. We're saving it twice. I'm going to reuse it the third time. Right. Huh. Because we're trashing it here. Probably work now. This is why I don't like having the that there is because of the ASCII keyboard. That gets rid of the ASCII keyboard data. This is why I want to change the monitor to something different. Write my own. Yep, might be easier, but it might not be. Alright, yeah, as you can see, it's BCC echo. Shame we can't do a call to echo, but it's return to center RTS. Should do the same thing. Because that's a fall through, as it's called. Let's see here, where's my compilation? Build it, send it, turn it off first before I unplug it. Don't want to break it again. I think I'm using one of the ROMs I have, well not ROM, EEPROM that I fried. Wow, simmered. I managed to put the EEPROM around the wrong way in the in its chip carrier and got quite warm. Maybe the other thing is that there's damaged components because of that, and that's what I'm fighting at the moment. But I'm being stubborn, and I'm going to turn it on that way. Okay, that took a while. And 50.55. Nope, it doesn't want to work. What the F? Okay, I'm going to hit my head against the wall soon. Alright, let's go back to... Okay. Yeah, that's off. Okay, this is the last compiler, then I'm going to leave it for the afternoon. It has an hour long. It's restoring it back to its original defaults. Program it. Nothing wrong with the compiling. It's the programmer. And close the chip carrier. Load the file. I don't want to select it, I just want to program it. Alright, now if this returns back to normal, I'm going to be happy. If it doesn't, I'm going to be we'll find out next time. Or I'll just turn this off and carry on programming. Okay, so all we were messing with is your load and store. So store echo, store load echo, load echo. We've been storing it twice and restoring it twice. So that one there is fine. And this is all because I feel that we are trashing the stack. So of course, when reading that stack, it is also changing as well. I'm just thinking, is there a way we can save the stack? So DA, that's a... Pretty sure DA is... Where are we hiding here? DA. 0D, 0D. Okay, so we'll look for 0D. There's a 0D. That potentially could be the return character. But DA... you know what? We could do a bit of code. we're going to cheats. Let's see here. Okay. So at location 50, location 60, we are going to write a bit of code. And the code we're going to write is, we're going to transfer the current stack pointer into index S, so TSX, which is a BA, and then we're going to do a transfer X, store X. Okay, so then we do a store X, which is an 86, into a 0 page memory location, which we will do 70. And then we do a 20, which is a JSR, jump to service routine, or I don't know, I think it's service routine. Hold up, my mic's disappearing again. Nope, I don't know where it is. Yes, I really should find where that mic is. I've got a decent mic. It's disappeared somewhere. Okay, jump to subroutine. 23 bytes. And the subroutine we are jumping to is the 00FF. And whatever that is, FF00, which is not the move, we just want to do a reset 0C. So that is the code. We will load at 60. And then 60.70. So at location 70, that 48 will give us the location, fingers crossed, of the current stack before we trashed it. No, it won't. It'll just give us the current stack location after we reset the processor, a cold reboot. So 60R, and it hangs, you bastard. Which is okay because I don't know what hangs. That's right. It hangs when we do the FF functions. So, okay, B0. So that's here. That's where the stack pointer is, B0. Because it will have run those commands until that command until it couldn't jump. But why is it not jumping? CFF. Yes, reload it. Okay, let's see if that has changed the address of my FF functions. Sorry, I did say it's out of time. So FF00, FF0C is my reset. Let's get rid of the stack stuff here. That could be causing us issues as well. Or is it? Oops. Okay, this is just the snippet of code try and do A6FF9A2038. I'm not worried about the stop, set, interrupt, disable, and then we go 60. This resets, would be fine. If it doesn't, it did do a soft reset. Okay. So why does not 20... Okay, so that's not running the code at that location, but interesting, because that works. All the jumps work. Okay, I'm going to have to go through the code and figure out what I've done wrong here, because there's something not quite right, and it could be in the editing of it, or the chopping up of it a little bit. But there's something not quite right with it jumping to a new location, and that could be to do with the compiler, which is something very easy to check. I'm just going to find out where it is and go from there. But that's it for tonight. It's been an hour and 10 minutes of me talking and getting nowhere. If you've learnt anything, that's good. If you haven't, that's also good, because I've definitely learnt something. We'll leave you guys and see you later.